As we gain experience with factoring quadratics, we observe that the general pattern will have constants of a, b, and c, and combinations of operations where perhaps b is added or perhaps it is subtracted, the linear term, and the final constant term is either added or subtracted. And there are only 4 real combinations of patterns. And we gain experience first by looking at a constant term where a equals 1 and realizing then that if we are going to factor as a binomial times a binomial, that the last times the last creates and is arrived at by factoring c. That is the beginning. And then the b term is arrived at as either a sum or a difference, depending upon whether the final operation in the trinomial is an addition. That then creates the sum for the central terms of b, or if it is a difference itself, a subtraction, then we will be finding a difference. So creating an organized list of factors and then their sums or differences helps us be efficient about determining whether a particular quadratic is in fact factorable or prime. Let us examine then the quadratic x squared plus x minus 6. Am I going to be able to factor that trinomial? X squared plus x minus 6. My analysis begins by realizing my c term is 6, so I'm going to be looking for factors of 6. The list would start with 1 times 6, 2 times 3, and that's the exhaustive list. Next, I need to look at whether I am finding a sum of c. No, it's a difference of c. So I know then that I will be looking for a difference of the b term. b in this case has a value of 1. So 1 and 6 have a difference of 5. However, 2 and 3 have a difference of 1. So I now know I am going to be able to factor, and first times first, x times x, I know that my signs will be different, an addition sign, a subtraction signs, different signs that have a difference of 1, but whether I put the factor 2 first behind the addition or last is driven by looking at the b addition sign. If I place a 2 here and a 3 there, my product negative 3x added to my plus 2 will result in a difference. That would be perhaps a successful factoring of this trinomial, but not this trinomial. So this is a factor that is a successful factoring, however, not for the question asked. That tells me then that my factoring for the trinomial will need to have x minus 2x plus 3. Now my outer 3x minus added to my inner 3x in combination with first times first and last times last is going to result in a successful factoring when I check.